Today we separate length from inner products. Because apparently even geometry needs a custody hearing. Every inner product space has a natural length function. But some length functions do not come from any inner product at all. A normed space is a vector space with a function that measures length and obeys three rules. The norm sends each vector to a non-negative real number. In other words, it is a length machine, not a mystery oracle. The first rule says only the zero vector has length 0. The second says scaling scales length. The third says detours are not magically shorter. Notice what is missing. No inner product, no angle, no orthogonality. A normed space gives length, and then stops answering emails. Given an inner product, define the length of V as the square root of the inner product of V with itself. Positive definiteness comes straight from the inner product axioms. Length 0 means the vector was 0. Shocking, yet useful. Homogeneity follows because pulling a scalar through both slots produces absolute value squared. The triangle inequality was proved last time from Cauchy-Schwarz. So the inner product length satisfies all norm axioms. So inner product spaces are automatically normed spaces. The converse, however, is false. Naturally, that is where the fun starts. On the real plane, define the taxicab length by adding the absolute values of the two coordinates. The usual taxicab distance between 2 points is just this norm applied to their difference. A taxi cannot drive diagonally through buildings. Sadly for urban planning. Its unit circle is a diamond. All points where absolute x plus absolute y equals 1. Euclid is already quietly leaving the room. It is positive because a sum of two absolute values is 0 only when both coordinates are 0. It is homogeneous because scalar multiplication pulls out as an absolute value. And the triangle inequality follows from the ordinary absolute value triangle inequality in each coordinate. Therefore the taxicab length makes the plane into a normed space. So far, no disaster. Suspicious. Honestly. Now suppose, for contradiction, that the taxicab norm actually came from some inner product. If that were true, every theorem about norms induced by inner products would apply, including the Pythagorean theorem. Let P be 1, 1, and Q be 1, -1. These two vectors will be orthogonal under any inner product inducing the taxicab norm. Indeed, write P as E1 plus E2, and Q as E1 minus E2. The cross terms cancel, and both basis vectors have taxicab length 1. But taxicab length gives length P equals 2, length Q equals 2, and length P plus Q equals 2. Pythagoras would demand 4 equals 8. Adorable. False. But adorable. So taxicab geometry is a perfectly valid normed space. But not an inner product space with that norm. Length survived. Angles did not get the invitation. A normed space keeps the length function and throws away the inner product machinery. Every inner product space gives a normed space. Because Cauchy-Schwarz and the triangle inequality do the responsible work. But taxicab length proves the converse fails. Not every geometry wants to be Euclidean. And frankly, who can blame it?